Hello, today we're going to implement a factorization number program in Python. We're going to implement it using some modern Python feature called assignment expression. And we're going to implement it in one line. So let's get started. Our program will stand on two statements. First is fundamental theorem of arithmetic. I'm not going to prove it in this video. And second statement, if we got interval of natural numbers from 1 to n, the first divisor of n is prime. So if I start from 1 and go to n, increasing by 1, 1, 2, 3, and so on, the first divisor of n will be prime. I will prove the statement in the end of the video. Okay, first function I need to have is a function which finds this first prime number. Okay, I get n on input and I need to go in range of numbers from 2 to n plus 1. And I'm interested in only divisors. And all I need is first divisor. Okay, let's check should this work or not. I call it f and I try to call it. And let's print the result. Okay, we got 5, and if I run it with 100, we have 2. Okay, the first divisor of 100 is 2, and it's prime. Okay, next I'm going to do is wrap the result in the list. So I just wrap it in a list and add additional condition. If n greater than 1, I can use this expression to generate this list. But if n is less than 2, then there is no divisors, and I will return empty list. Okay, because there is no prime divisors for numbers below 2. Okay, let's check this, and we got the list with one element 2. Okay, and if I put 1 here, we have empty list because there is no prime divisors of 1. Let's check it with 5. Okay, now we going to split the problem to sub-problems. If I found one prime divisor, using this and the fundamental theorem of arithmetic, I can divide my starting n number on that divisor. And so I reduce my problem to smaller problem. Okay, I will divide the n to this divisor, and the final set of divisors will be this divisor plus the set of n, the set of divisors of n divisible by this divisor. Okay, let's write this in code. I will use cool feature of Python 3.8 assignment expression, and say this list in variable p, assign the name to this expression, and let's divide our problem to subproblem. Okay, we're going to call our function f one more time, but with other number. This number is n divided by our first find multiple. Of course, we can do it only if we have some number in P. Else we cannot do it, and they will return an empty list. Okay, let's try to run this. And we got prime divisors of 100. Let's check it with 200. Okay, it seems to works. And for 1000. Okay, fine. And now I'm going to prove this second statement which I used to write this program. If I got interval of natural numbers from 1 to n, the first divisor of n is prime. Let's prove this by contradiction. Okay, if we found the first divisor and suppose it is not prime, so this divisor I call it d, and it will be I can write it as multiplication of two numbers because it's not prime. Okay, it is composite, so it can be written as multiplication of k and n. Let's call it a and b. Next thing we know that n is divisible by d, and so if it divisible by d, and as d is representable as a multiple b, we can conclude that d is also divisible by a, or d is also divisible by b, and a and b is less than d. But we start this statement that d is the first found divisor. So we got to contradiction because we show that B and A are less than D, but this is impossible because D is the first found divisor. We start from smallest number 2 and going increasing by 1. Okay, so D can be represented as A multiple B. A and B not exists. So D is prime number. They prove it. Okay guys, thanks for watching and sorry for my English.